Alright, welcome back. Today we're going to be looking at rational and irrational numbers and just some of the general terminology we need to be aware of. So until now we've been operating with everything under the banner of real numbers. And included in real numbers is rational and irrational. Right. Now, rational numbers are anything that can be written as a fraction where the numerator and the denominator are both integers and the denominator cannot be 0. So this is anything like minus 3 over 2, 1 over 2, 1, 4, anything like that. Whereas an irrational number is also part of this set of real numbers, but it can't be written as a fraction of two integers. Some examples are pi, minus 105 over 5, root 3, negative root 3 of 4. Anything where ultimately what's going to happen is if we were to solve, say, this division problem, turn this fraction into a division problem and solve for it, what we would get is a decimal value or a decimal number that had no clear pattern and continued indefinitely. So let's just quickly talk about that. So when we talk about a rational number will also be, if it's a decimal, it will be repeating or it will be terminating. A repeating decimal is simply any decimal number where the digits repeat or they repeat in some kind of pattern. And one of the most common ones we know of is obviously that if we were to do 1 over 3 and solve it, we would get 0.33333. Okay, and that would continue indefinitely. And the point here is ultimately that a recurring decimal number is going to be rational, and a terminating decimal number is just any decimal which ends. It doesn't continue forever. Alright? That is also going to be a rational number. Where a number has no repeating pattern, continues indefinitely, that's going to be irrational. And we're going to use this information to solve some problems we're looking at today. So let's get started. Firstly, let's make some space. Alright, so we have a few things to look at here. We have our questions, and we're determining whether or not each one of these is going to be rational or irrational. So let's start with A. Is the square root of 10 going to be rational or irrational? Now, anything where we have a square root, if it's not a perfect square, that is if you perform the function and it does not result in a whole number, or something like 3 or root 16 resulting in 4, then what we have is an irrational number. So this is irrational. Now if we look at B, we have 0.25. This is a terminating decimal, and because it's a terminating decimal number, it is going to be rational. And if we look at C, we have root 2 over 5. Now because this is expressed in a way where we don't have two integers in a fraction, one for the numerator and one for the denominator, this is irrational. Alright. Alright, here's a couple for you guys to practice, so just give the video a pause, give them a go, and then I'll solve them in just a second. Okay, let's get going. So for D, we have 2.789654, and it continues forever. Now this one we just have to check and see if there's any recurring pattern in these numbers, and it doesn't appear to be. It could be a longer pattern of numbers, but for this purposes, for this one, we're going to say it's irrational. Alright, we have 4 over root 16. Now, because it has the square root in the denominator, we do have a temptation to consider it as irrational. But remember, if we can solve that square root, then we can, and get a rational value, then we can find that we might have a rational number. So if we solve the square root of 16 being 4, then we actually have 4 over 4, which equals 1, and this means this is a rational number. Okay, for f, we have the square root of 18 plus pi. Now, the square root of 18 is already irrational, and pi is irrational as well. So we're adding two infinitely recurring decimals with no clear pattern to each other, so this is going to be irrational. And you can check this on your calculator. It will stop at a certain number of decimal places. It won't keep going, but you're just looking to see if there's any recurring pattern to this that ultimately will make you think it might be rational. Alright, that's it for this video. Hopefully it was helpful, and I will see you in the next one.